And there we go. All right, so you guys have your graphing calculator? It's going to be a bunch of graphing calculator stuff today. So how do we solve the matrix equation AX equals B for X there? So how do we actually solve that for X? Well, how about this? How about I just, excuse me, tell you the steps to do, the buttons to push, without any good reasons, and then I'll go back and give the reasons afterwards. All right, so all you have to do is basically put A in, so step one, put A in your graphing calculator. Sorry, my Apple Pen is broken for some reason. I'm writing with my finger, so hopefully it'll be legible. Put A in your graphing calculator, and then also put B in the graphing calculator. So put A and B in the graphing calculator, and then take A inverse times B. And that's it. And that'll be your answer. A inverse times B. That's a times there in the middle. A inverse times B, and hit equals, and that'll be your answer. It's as simple as that. So you guys have your graphing calculators? Let me let you do that, and I'll answer any questions you have. So do you remember how to do the graphing calculators? How to enter matrices? Do you remember all the steps for entering matrices? A good time to review since our test is day after tomorrow, right? Thursday. So I can write some steps up if that's helpful. Yeah, let me go. I'll go grab mine. I forgot to bring it with me. To help you after class, I can go on YouTube's with you and check that out. All right. So hit for the TI-84 and 85 and 86 and those kind. You basically hit second matrix. Right? Hit second matrix, and then it goes into matrix mode, and you go over to the edit menu and hit enter. That's a funny looking enter. Trying to write with my fingers here. Enter. And choose the size of the matrix, 2 by 2. 2 enter. And then type in the matrix. The 1, 7, negative 2, 5. And then hit second quit. Because once you've got it typed in, it stores it in its memory banks automatically. So you just quit, go back out of that mode, and then you go back in for matrix B and put that all in. So B's kind of the same. And then after you've got A and B both in there, then enter B, and then quit that. Second quit again. Then enter B and second quit. So enter A and quit, enter B and quit. After you've got them both in there, then you go back to the, kind of running out of room, I have to go to a fresh screen. So hopefully you got that copied down if you need it. Everybody got that down? So there's the instructions for entering matrix A and entering matrix B. And then after you got them both in there, what you have to do is hit, what, I'm a little bit unclear myself. Oh, second matrix again, and just hit under names, which you're already under, for A, hit enter. And that just pulls matrix A to your main working screen, you know? That just puts it on the main screen. And then, so down here on the main screen, that'll pop an A once you do that. That naming it calls it forth, right? You're just naming it. You're saying, go get matrix A calculator out of your memory banks. And then you have to hit the inverse key, x to the minus 1 key. That's the same key that has the word matrix above it. Hit the inverse, and then hit times, and then do the same thing and go second matrix. So hit inverse, hit times, then hit second matrix, names, and you go down to B and hit enter. And it'll go A inverse times B, and then hit enter one more time, and it'll do it. All right, what's the answer you guys are getting? -2. Does it show it vertically? Yeah, -2 and 5 like that? -2 and 5. Is that good? Questions I can answer on that. Are y'all getting that?
You don't have to use the times key
Oh, don't you? Some calculators you can just put it right next to it and does it automatically, huh?
for the 84.
Good deal. All right, for the 84, don't need the times. Yeah.
Why would you inverse it?
Yeah, I haven't given any reasons for any of this, have I? For the first time, I just want to get you the steps, but then I'm going to talk about, so let's talk about why. Why is that? So everybody okay with the mechanics? I'm making that happen. Yeah, why is that? I'm glad you want to know. I'm glad you're not just here to do monkey see, monkey do, but you want a logical reason behind it. Because that's what I enjoy about math too, is the reasons. Like, why is that true? Think with me about this for a second. Think if I gave you a simple equation like 2x equals 7. Okay. Now, that x is just a regular x. You know how to solve that from your algebra days, right? What do you do to solve that then? Divide by 2, right? Just divide by 2 on both sides. X is alone. Boom, right. Now, let's go back and do that again. And I want you to think about dividing by 2 in a different way. You're, of course, right. That's true. That's how you do that. But think with me this way. Instead of dividing by 2, I could multiply by something. What? What would, instead of dividing by 2, what's the same as, what will get rid of that 2? What can you multiply by to get rid of that 2? A half. Half of 2 is 1. That'll just be 1x. That'll just be x, right? Dividing by 2 is the same as multiplying by a half, is my point, right? And whatever you do to one side, have to the other, you get the same answer, 7 halves, same thing. It's just another way of saying the same thing, right? Now, why am I doing that? Well, because I want to show you that what half is the inverse of 2. We don't talk that way. We just go divide by 2. But as you move into like higher math, we're in a different world now. We're in the matrix world. When you're in the matrix world, and when you go into like higher math later, beyond calculus, and you prove things and you get a math degree, you basically learn how systems work. Not just this or that, but like a whole system. And what we have in systems of mathematics, like matrix is a world of math unto itself. Different than just the regular number world, right? We have the matrix world and the regular number. Well, what we're doing when we divide by 2 on both sides, really, we're multiplying by the reciprocal, the inverse. So all the elements in a world, in the matrix world or in the real number world, have inverses of themselves, right? Half is the inverse of 2, isn't it? Okay, so what? Well, that's what we're doing. When they give me AX equals B as a matrix equation, I can't divide by the A, right? If I could divide by the A, then that would get the X alone. That would be how to solve for X in the matrix world. But there's no such thing as dividing by the matrix A. Instead of dividing by A, how do I get rid of the A? I multiply by the inverse on both sides. It cancels it out. X is alone, and what is it? A inverse B. That's why A inverse B is the answer to the matrix equation. It's the same thing as dividing by 2 in a regular equation. It's just dividing by 2 is the inverse. So it's A inverse on both sides. Now, one thing that matters in the matrix world that does not matter in the real number world, and that's the order. I don't know if you spent time with Mr. Karambakis. Did you enjoy Mr. Karambakis? You should. He's a fun guy. You should have asked him. I don't know. I should have told you ahead of time to ask him to tell you some stories about Caltrans. He was a manager for Caltrans for years. And why I say Caltrans? Because you know Caltrans has all the jokes, right? Do you know what I mean? What are the jokes about Caltrans? That they're not doing anything, right? You drive by and you're on the freeway and you see, 7 guys leaning on a shovel and 1 guy's digging, right? And they're all watching to make sure it's going right? And you're like, what are those guys doing? I'm paying my tax dollars. What are they doing? So it's a joke. And Karen Bacchus, he knows it very well. And so what I like to, when I hear those kind of jokes, I like to find out, is it true? Or is it just made up, right? So when I first met him, I don't know, 5, 6 years ago here in the department and got to know him, he was still there. He was still at Caltrans at that time, managing and just teaching a couple night classes. Now he's retired and he teaches more for us. Anyway, I said, Spiros, tell me, is it just like true or is it false or partly true? That's the deal? You're there. You're a man. He's actually a manager over several departments and stuff. And he said, it is totally true. He said, they are just lazy. He said, he was always complaining to me, like all the time. Every time he sees me, I said, I try to go to work today and I tell the people to do stuff and they just don't go in their office 8 hours. They get nothing done. He said, I can't fire them. I can't fire them because there's all this paperwork and bureaucracy and you can't fire them unless they blow up a truck or something. You just can't get rid of them. They know it. They don't do any work. Anyway, it's funny. It's just funny to talk, go right to the source. And that's his opinion. Just ask him. He's got great stories about life at Caltrans. I have found that most stereotypes have a pretty good kernel of truth to them. That's why they've become, that's been my experience in life. I don't know if that's popular to say. I'm just telling you what I've seen. Anyway. All right, back to it. So I hope you had fun, or if you ever have, I'm not planning to miss any more days, but if you ever have Mr. Karen in some other class or something, ask him to tell you a Caltrans story. All right, so that's what we're doing. That's why it's true. You're doing the inverse of both sides. So that's the logic behind it. All right, so, yeah, there it is. Yeah, so it's the same kind of thing. You're just going to take A inverse, and then you're going to type in A, get it on your screen, and go times B and hit equals or enter or whatever. Yeah, there's nothing more to say. Same exact thing. Let me. All right, so in this case, what is matrix A? Can you tell what A is? A is the numbers over here, right? That's A. This right here is B. I'm getting kind of scribbly here. So let me be a little more careful. I can't do it very well because my finger, I don't have the pencil. Well, I got the pencil, but it's not working. This is B, and this is A. Right, we good on that? So can you enter matrix A? So matrix A then would be, what would it be? It'd be -2, -1, 7, 0, 4. Everybody see where that 0 came from? 5, -7, 3, 6. So there's matrix A. And then B is, I think I covered one of the negative signs up. Yeah. B is -40, -4, -40. So it's the same kind of thing. Take A inverse times B. Am I on the screen? Yeah. And it equals, and you got it. Make sense? Is that good? Same kind of thing. So they want you to find A inverse. Here they want you to enter A inverse. That they're going to break the question into two parts. They want you to type in A inverse. And then be, oh, by the way, sometimes they come up decimals and they want fractions. That's what you were going over, Monique? Good. Yeah. Do you guys know how to change the answers to fractions? Let me put that on a fresh screen here. If you get decimals, and you can, if you want to, you don't have to, but if you want to change to fractions because it asks for it, yeah, because they make you. So if you want to change to fractions, just when you have the matrix on your screen, just hit math, enter, enter on the TI-84. Math, enter, enter. Because that changes any decimal answer to fractions. That's what that does. So that's once you have the matrix, you know, when you have something on the screen that you want, a decimal, or a big matrix with decimals, that you want to change to fractions, when it's on the screen, hit math, enter, enter.
Where's math on here? Or is that gives you an option once you do it?
No, it says math.
Yeah, the actual button on the left side, math. There's a math button like fourth down on the left, third down on the left side. Yeah, so once you have your matrix. Why, did this one come out decimals?
Yeah.
It did? Okay, yeah, let's do it. Let's do this one then. So go ahead and type it in, and I'll get it as well. My little thing here. So let's type this one in. Okay. So I'll tell you what I'm getting. So I got, when I did the A inverse, I got like, you know, a bunch of ugly decimals, 0.04, blah, 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 blah. And then I hit math, enter, enter, and I got 371s, 371sts, I guess it is. 971st. What's that over there? Minus 11 over 71. This is 10 over 213. These are messy. And minus 8 over 213. And then minus 35 over 213. Sorry, it's kind of messy. It's the best I can do with my finger. I don't know why my Apple Pencil is not working. 37 over 213. And 13 over 213. All right, there's what I got for the inverse matrix. You guys getting that? When you hit second, or hit math, enter. And then you gotta take and multiply by b and get the final answer. Is the other part they want. Let me. All right, grab me after if this you're not happy. It's not.
It's going to be RREF.
Yeah, when we do REF, we enter the whole thing, including the right side. That's the difference. Do you remember that? Remember back when we did? So you could. Well, let me do it the new way. So the new way. Not the now, but the new. Yeah, see the difference? So they're both on the test, so which is day after tomorrow. So it's good that I remind you. The new way is to take A inverse times B, right? The old way, the RREF, was to do RREF of the whole thing, meaning 1, 6, minus 3, 1, and 6, the right side. 3, 1, 1, 3, negative 8, and 6, negative 1, 1, negative 1, negative 10. And the REF was a little quicker. The old way was a little quicker. Yeah, just RREF, that whole thing. The entire thing, the A and the B, the whole thing. Right? Everybody good with that difference? I don't want you to get those confused on the test after tomorrow. So you can enter the whole thing, the A, the B, the right side, the B, the whole thing, RREF, boom. That's the quickest way. And they'll just get you right to the answers. Which is fine. If all they're asking me for is the final answer, you can just do RREF if you want. That'll give you the final answer. But if they ask you to give them a halfway result, like they did on the last problem where they said, just give me the inverse now, well then you're going to have to play their game. You know, you can't, RREF just jumps right to the end. It doesn't tell you anything about halfway through. Everybody see what I'm talking about? So the new way is the A inverse B, where you just put in the A on the left side, the B on the right side, A inverse times B. The old way, whole thing, A and B, RREF, it's done. Same answer in the end, either way. Same 4 answers. Is that good? Is that making sense on those 2 ways? Questions I can answer? What's the answer you got? Did you guys get an answer?
Negative 2, 2.
Negative 2, 2.
2. Negative 2.
Like that? Anybody else getting that? Nobody else getting that? Well, I don't got time. I'm going to move on. I'm going to hope that's probably the right answer. It's clean. Didn't come out weird. It's probably right. Yeah. Set that one up. Okay. Electronics company produces transistors, resistors, and computer chips. Each transistor, 3 units of copper. I would just set these up in a big old table, probably. I think it's the easiest thing. So I'm going to go, okay. Transistor. And then there's how much copper, zinc, and glass. So, okay, so each transistor, it says 3 units of copper, 1 unit of zinc, 2 units of glass. Each resistor requires 3, 2, and 1. And each computer chip requires 2, 1, and 2. How many of each product can be made with 400 units of copper? So now they're giving me the totals. 400 units of copper, 235 units of zinc, and 215 of glass. Solve this exercise by using the inverse of the coefficient, blah, 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 blah. So there's that. Now, you can have that big old table, but how do you know what your X and your Y and your Z are? Well, it's all about what they're asking for in the end. See what they're asking for? What do they want? What are the three answers they wanted? And that's your X, Y, Z. Transistors, resistors, and computer chips. This is X, Y, Z. Does that make sense? So I've actually kind of got this thing a little bit backwards, which is fine. It doesn't matter. You can set it up. So these are X all the way. These are Y all the way. I'm not going to rewrite my table. This will be fine. Like that. And then this is one equation, isn't it? Right? 3x plus 3y plus 2z equals 400. I did them vertical instead of sideways. And this is the second equation. Add, equals. And this is the third equation. Add, equals. Does that make sense? Normally we have it going sideways instead of vertical, but it's the same deal. You just put that in your calculator. So yeah, so you will need to turn it. Yeah, we will need to put it in like this on our. Oh, I'm getting lost on our calculator. It will need to be like this. In other words, this guy will have to go across the top. 3, 3, 2, 400, and then this guy in the middle. 1, 2. 1, 2, 35, and 2, 1, 2, 215, and I would just do RREF because it's quicker. See what I just did, guys? I turned it sideways because you do have to have the X's. You have to have X's all the way down here. Right. In fact, I should just say this. So you have to have X's here, Y's here, Z's here. And that's what I now have. Everybody good with that? Am I confusing you? Just making sense? So when you put it into your graphing calculator, you do have to have X's down the first column, Y's down the second, Z's down the third.
15, 85, and 50.
What'd you get?
15, 85, and 50.
15, 85, and 50, 50?
Yeah.
Okay. Anybody else get those answers? That's for X, Y, and Z. Transistors, resistors, and computer chips. Yeah, you know what? It would have been easier. Here's what I should have done, guys. Here, now that I'm thinking more straight, let me redo this. It's okay. I mean, what I just did was okay. But if that's confusing for you, having to, switch it up, turn it sideways and everything, and you want to not have to have that problem and get yourself perhaps confused on the exam, what you could do is just is whatever they ask you for, that's your X, Y, and Z, and you want those going sideways. So just make those sideways right away instead of what I did and made it vertical. Just take transistor, resistors, and chips, and just put those sideways. Right away. And then down, and then what are the other things? Copper, zinc, and glass, right? Like that. And then then it'll be easier, because what does it say about transistor? 3 units of copper, 1 unit of zinc, 2 units of glass. And then 3, 2, 1, and 2, 1, 2. And the total for this The total over here is 400 for copper, 235 for zinc, 215. That way it'll go straight into a matrix. You don't have to turn anything. So everybody seeing how I did that a little easier way? So when they give you their three things they want, the three answers they want, that goes right across the top. That goes sideways. And that'll always make you have it straight. Everybody see that? Make that the easiest way possible. So whatever they're asking for, whatever they want from you in the end, just put those right across the top. And then fill in the rest of the thing. And those numbers will exactly become your matrix. No need to turn anything. If you put the things they want right across the top. And then fill in the table. Just type it straight into your calculator with RREF. And you get your answers. 15, 85, 50. Anybody else get these? Yeah, good. A couple people got it. Good. Looks like it's right. Is that good? Questions on that? So whatever they want from you, straight across the top. And the rest of the table will work straight in your calculator, RREF. About coding and encoding and stuff like that. So, all right. So, it's a whole deep area of mathematics, is coding and encoding and twin primes. I don't know if you've read much about how they do all that. Very, very interesting kind of stuff, all that coding and decoding stuff. And what I think is very interesting is I enjoy reading about all the coding and encoding they did during World War II, between England and Germany, and trying to figure out each other's codes and doing different things, and it's very interesting. We got the German boxes at one point, right? And so we knew a fair bit of their communication. There were times when we tried to cover that up. See, I'm doing history again. I'm a history wannabe teacher. Real quick. There were times we tried to cover that up. Like we knew, for example, one time there was a boat coming through, a German boat, and we normally bombed them. And we knew there was a bunch of our people on there, prisoners of war, American troops. And so we naturally didn't want to bomb it. Had a bunch of our own people. But we had always bombed the ships coming through that area. And we thought if we don't bomb it, they're going to know we have all their codes. And that's going to cost us more men in the long run. So they bombed their own men lightly to keep the secret. Anyway, a lot of interesting stuff about how the coding and decoding and all the battles went with that knowledge. A lot of it was a war of knowledge. Anyway, so on this one, this is like one example of how that might be done. What do they want me to do? They want me to take the words come home and break that into, am I on the right screen? Yeah, all right, I moved it over, good. So I want to break that into code. So how do we do that? All right, so let's take the word C-O-M and then E blank H and then O-M-E. Those are the three I'm going to enter. This right here is a space, right? If you read the words, they tell you to count spaces. So C-O, and they want me to break them into 3 digits at a time, counting spaces. So I did C-O-M, because that's 3, and then the E space H, and the O-M-E.
Okay.
3, 3, 3.
I have one that said I am something. So if it's I, then it's going to be a space.
M, yeah.
And
I
then-
space A.
And then, okay, I space A. Okay.
Right, you break it into 3, 3, 3. So the spaces count. So you'd go I space A, break, M, whatever. Just keep going. Does that make sense how I broke that up? Yeah.
You always carry the first letter of the second word, or?
No. Just break it by 3s. Let me show you again. Let me go back to the original. So coming up here, C-O-M, break. Oh, I see. I can't do it. It's too small for me with my finger. So I'll write it down here. So I'm just simply taking the word come home, which is 2 words, and the space in the middle counts. Right? That makes sense? And they're telling me just break it into groups of 3. So 3 letters, break. E space H, break. O-M-E. Make sense? Just break it into groups of 3. That's what they're saying in those words. Okay? And now you put code numbers. You put numbers. For instance, how do you do the numbers? Well, they want me right over here. It says A is 1, B is 2, C is 3, etc. And the space is 27. There's 26 letters in the alphabet. Z is 26. And the space is 27. See it over here? Space is 27. So then this C-O-M would be what? 3. C is the 3rd letter in the alphabet, A, B, C. And then O, I don't know. We count it out, I guess. A, B, C, D, E, F, G, H, I, J, K. Wait, I took it. 15, yeah, 15 is what I got too. Do it a couple times. It's easy to mess up. 15, O, and M is 16, right? No, it's 13. Is that right? M-N-O, right? 13? You guys with me? 3, 15, 13. That represents C, O, and M. Okay, then E is what? 5 spaces, 27. H, A, B, C, D, E, F, G, H, 8. 5, 27, 8. And the O again is 15. M again is 13. E is 5. So there we go. So we have 3 numbers, 3 numbers, 3 numbers, representing 3 letters, 3 letters, 3 letters. So far, so good. Now, we want to turn those, we want to encode those, because if we just keep them like that, anybody can figure that out, right? But then you have an encryption key. The key is this matrix right here. We're going to take these 3, we're going to turn them into 3 by 1 matrix, column matrices, and we're going to multiply them by the B, which will encode them, change them. And so if we had a buddy or an ally on the other side of the message, and we would have told them our encryption key ahead of time, they would take the inverse of that and then uncode them. That's how they would reverse the code. Does that make sense? The matrix B is the key. It encrypts and encodes and decodes, right? B encodes things. B inverse will uncode them. So what they're saying is, all right, how would you, so you take the 3, 15, 13, right? My first 3 right here. Do them in groups of 3 at a time. 3, 15, 13, and I'm going to multiply that by matrix B. Are you tracking with me? And that'll turn it into 3 different numbers encoded. This matrix B here. All right, you good? I need a fresh screen, so I'm going to move that. So let's see. All right, so again, what were those numbers? So 3, 15, 13. So I'm going to take the 3, 15, 13, like that. Okay, and then I'm going to multiply it by matrix B. And this is wrong. Don't write this down. I'm purposely doing it wrong because I want to show you something that might confuse you. You can't multiply them that way. It's got to be the other way. Meaning you got to put it over here. How do you know? You tell me.
Telling me error.
It'll tell you error. Yeah, other way. How do you know which way to do it?
1 by 3.
You guys and Mr. Karambakis talked about it. I'm hoping you know the answer for me. Remember the sizes of matrices. So this matrix here, is this a 1 by 3 or a 3 by 1? It really matters that you know which of those it is.
3 by 1.
True.
It's down first. Down first. Really important. It's the opposite of graphing. You know when you graph things, which we're going to start next week, you go over first, then up, right? Matrices is down first. So that really matters. This, therefore, is a 3. Whoops, that's not what I wanted to do. This is a 3. My finger just keeps hitting it. All right. 3 by 1 matrix. 3 down, 1 across. Okay, so what? Well, this is a 3 by 3 matrix. Okay, so what? If you're going to multiply 2 matrices, did Mr. Karambakis tell you? The inside numbers must be the same or you can't do it. And your calculator knows that. It'll tell you error. If you put the 3 by 3 over here, then the inside numbers will match. The 2 3s inside, and it's a go. Does that make sense? The order in which you multiply 2 matrices matters. When you do it, the 2 inside numbers must be the same, or it's not allowed. So that's how I know that I don't want to put the 3 by 3 on the right. No. I want to put the 3 by 3 over here, the 2, 4, 6, -1, -4, -3, 0, 1, -1. I want to put it over there, not on the right side, but on the left, because that makes the numbers inside work. Right? Because then we have a 3 by 3 and a 3 by 1, and the 2 inside numbers match. Everybody seeing that? So it's a go, right? So the inside numbers have to be equal for you to even be allowed to do it. And then the answer matrix is the outside numbers, the size of it. So the size will be a 3 by 1. It's these 2 outside numbers. The size of the answer matrix will be 3 down, 1 across. Did you know that? Did you catch all that from your time with Mr. Karambakis?
Yes.
Right? The inside numbers must be equal, And when you do it, when you multiply matrices, and the answer will be, the size of the answer base will be the two outside numbers. So, okay, so hit that on your calculator. What do you guys get?
So B's not an inverse, it's just the B times.
Yeah, oh yeah, no inversing here. It's just A times B, straight.
Okay.
No inverses of anybody. Yeah, inverse is just when you're trying to get X alone,
Okay.
right? And we had to, just like dividing by 2 or something, we had to do the inverse to get A off of X. So, somebody give me the numbers there.
144,
What is it?
144, negative 112,
Uh-huh.
and 2.
And what?
Just 2.
Just 2, okay. Anybody else getting those numbers? Yeah? Okay. So we have just encoded the first 3 letters of COM, right? Come home, COM. This is the code for COM. The only way they're going to uncode that is if they have our B matrix. Then they can get inverse and hit inverse on this. It'll turn it back to the way it was. That's one form of encryption using matrices. Makes sense? So that they want you to do that for all 9 letters. All right. I think with half an hour we have left, we should look at the practice exam, huh? What I mean. Okay. So you see these 4 formulas up here? The way they are in the practice exam looks a little different. Because other semesters I taught them that way, but I realized this semester it's easier for students to understand if I show the full form. Well, that's what I'm giving you on the real exam. Notice what I mean is, this first one, for example, instead of the way it is there, the way we did it in class a month ago when we did it, or 3 weeks ago, or whatever it was, is it's close, but instead of I put, what did I put? R over N. And instead of N, there I put NT. Yeah, that's what I did. Like that. See, I didn't put the I, and I didn't, it was a little different. Anyway, that's the way it'll look on the real exam. It'll look like what you're used to, in other words. So I don't want you to be confused as you look at the practice exam and think, oh, he's changed the formulas. It's just a different way. So if you want to write them, so this is the way, if you want to put this in right now, there's the way the first one will look on the real exam I hand you day after tomorrow. It'll have those 4, it'll have this one at the top. You guys got that one copied down? Basically, it's the 4th one's unchanged. That one, oh no, that one's changed too. Yeah, in all 4 of them, everywhere you see I, it's R over N. And everywhere you see an N alone, here's the changes right here, and right there, and right there. There's where the changes were. Instead of N alone, it's NT. Instead of I, it's R over N. And that goes for all of them. That's the way we did it. I'm just showing you all the details. So that's what you'll see. You'll see it like this, what you're used to, what we did this semester at the top of your exam day after tomorrow. Not the way they are in the practice exam. So hopefully that isn't confusing. So we got that one, and the other ones are the same. All right, so let's move ahead. So just use the formulas you're used to. Do you want me to write them out? I mean, I can do that. Here's the second one. It'll be S equals R, 1 plus R over N to the NT plus 1 minus 1 all over R over N minus 1. Like that. So there's that one. I don't know if you want to copy these down. It's just the way we used them before in this class, this semester. So again, I became R over N, and N alone became NT. On that, is this something you even want? Am I just wasting time? You guys got that copied down? It's a couple of minus ones,
That's
right?
NT plus 1.
Yeah, NT plus 1 up in the power. Mm-hmm. Yeah, NT plus 1. Right, it's the same as this, except it's NT. NT plus 1, then minus 1 here, minus 1 in the back. Got that one. Everybody got that one copied down? And did you get that last one? Did everybody get this one copied down? That's the first one. So I should have just circled this first one. So there's that one. I want to copy that one down. This is the way to look on the test day after tomorrow. Give you a second. Is that good? Can I move on? You got that one? Okay. And then let's do the third one, and we'll be done with this. So then the third one here is going to be P equals R, big old bracket, 1 minus 1 plus an I again is R over N, to the minus, and N is in T, over R over N. So that's the way it'll look on the test day after tomorrow. So let you copy that one down. All right, good. So we got those down. So ready to work on some problems. So I think what would be most beneficial in these last 25 minutes we have together is to help you with identification and then solve like maybe 2 or 3. Because there's 2 or 3 that are really hard. I want to do those hardest ones. But generally, I think the main issue is identification. I think if I can help you say, oh, when I see this, it's this formula. If this, it's that formula, right? You can normally work out the formulas if you just know which one you're supposed to use, right? Except there's like 2 or 3 that are extra hard, where you got to use, actually one of them you got to graph the 2 things and see where they hit. That's number 3. I'd like to do number 3 with you. I show it on the practice exam, and I show the graph and everything, but it's a hard one. Number 3, number 25, I think, and one other one. I can't remember now. Anyway, all right, here we go. These first 7, these four formulas in there. You get a 3x5 card also, right? Put anything you want on a 3x5 card also. But you get these 4 formulas at the top. All right, how do you know what you're supposed to use when? Let me give you a couple big rules to know. First off, payments, whenever they talk about payments, that's an annuity. An annuity means payments. So if you read any problem and they go blah, 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 regular payments, you know you're supposed to use one of those 3 annuity formulas. Payments equal annuity. All right, now how do you know which way it is? We have 2 ways. We have the so that's first fact. We have the pile at the beginning, and then payments. This is called present value. And how you know is the payments are coming off the pile. And then the other case is we have like little payments building up to a big pile later. Payments, instead of coming off, they're building up. And this is a future value because the pile is later. It's in the future. I'm trying to help you distinguish whether it's a present value or a future value. It's all about what the payments are doing. So this would be like, well, I'll give you examples, but I'll warn you, they can be a little more tricky than just exact examples. It is they. You might think, what do you mean they? It's you, mister, and you're writing. Well, I am, but I'm just getting them out of the book. I'm just getting them off the publisher's website. So some of these questions, they're a little tricky. So let me, like this would generally, like the one down here, this is usually, generally like retirement. You know, I'll say saving for retirement, right? When you save for retirement, you're building up for a big pile in the future, right? You're saving it. You're making payments, building up for a big pile in the future. Saving for retirement, that's future value. Whereas present value might be something like a house loan, right? You get the big pile, the money to buy the house now, and then you pay off that big pile. Your payments come off of that pile, reduce that pile, until one magical day, I've heard, your house could actually be paid off. Never experienced that. So, right? That makes sense? So typically then if they give you a house payments or a car payments or things like that, that's present value. Pile now, because why? The payments are coming off, right? You're paying off the big pile, the big house, the big car, whatever. Whereas saving for retirement, the payments are building up for a future pile, right? So I put that on my 3x5 card. This would be a great thing to put in your 3x5 card. Now, you know, payments equal annuity. That's an A up there. Payments equal annuity. Payments equal annuity, and present values like a home loan, or instead of home loan, I should say house payments. You know, house payments or car payments, because the payments are coming off of the pile, and saving for retirement is a future value. Now, within, which one is it? Present value, future, ordinary.
And due.
Oh, we have the two futures. Okay, we have the two future types. Two future types, yeah. So let me mention that one last thing. I don't know if I have room to do it here or what I should do. So for the future, yeah, I got to go to a new screen. For future value, whoops. Come on. For future value, which means, you know, like you're saving for a pile in the future, like retirement kind of thing, there's two ways. So that you know the payments are building up, right? That's what it means to be future value. Payments are building up. So payments are at the end of each month or whatever. That's ordinary. That's what they ordinarily do. Payments at the end. If the payments are at the start of each month, that's not ordinary. That's a little different. That's called an annuity due. They're due at the start. Those are the two, that other distinction. So that's what I would put on my 3x5 card. That's what I wrote in those two screens. I mean, that's probably some other things too. Does that make sense? I want to go through those first 7 or 8 problems with you then and name that tune, you know, name that formula as we read them. But everybody got that stuff down? Is that making sense? So don't confuse in your mind. There's two things that could easily be confused. There's the big old pile, now or later, and then the payments, start of the month, end of the month. It's two different things, right, that we're dealing with. So the pile now, present value, that's like buying a house. And the payments come off of that pile, right? Present. First, decide that. Pile later, that's payments building up to a future value. And then there's two ways to do future pile. The payments at the end of the month or the beginning of the month. For the other one, for a present value, they don't do it two ways. They just do it one way. All right. So let's go there. Was that too quick? Everybody get that down? We good? Anybody else need to copy that down? Got that? So the ordinary annuity, ordinarily it's at the end of the month. Annuity due, start of the month. All right. So let's go for it. Let's go and actually solve some of these. All right, so looking at number 1. Let's read number 1. Let me give you all a chance to figure out. I just want you to say which of those 4 formulas up there is number 1 going to be. So don't say it out loud. Give everybody a chance. So just number 1. Payments of $10,000 are made at the end of every quarter. Interest is compounded quarterly. What amount will be built up? There's the key phrase. Ask you the first distinguishing mark, the first thing. Don't worry about this made at the end. That'll matter, but not a lot, not right now. The big thing that matters is that phrase, built up. Because that's telling you whether the payments are building up to a big pile or they're coming off a pile. Right? That's the main thing that tells you pile now or pile later. Pile present or pile future. So they're building up. So where's the pile? Future. Future. So it's some kind of, so you go up here and go, oh, it's either this one, or this one. It's one of the two future value ones, right? Because the pile's in the future. So notice I didn't, now, how do you know which one it is? What tells you, is it ordinary or annuity due? What'll tell me that? Now we go to the end, yes. We didn't do the end first, but then we go, oh, end. Whoops, where's my pen? End of every period. So end, that's what's ordinarily. That's normally things are due at the end of the month. So that's this one. Future value of ordinary annuity. If they had said beginning of every quarter, I would have went with this one over here, because that would be due at the beginning. Make sense? So we know which formula to use. Let's go to number 2. So take a look at number 2. Give you a chance to try it on your own. Decide which formula. By the way, let me add this. The compound interest formula, we haven't used that because that one doesn't involve payments. So any problem that talks about payments, I think these first 7 all talk about payments, it's going to be one of the annuity formulas, one of those 3 annuities. It's not the compound interest, right? Payments mean annuity. Remember, that's the first thing I wrote. All right, so payments, all right, so it's some kind of annuity formula. It's one of those 3. So ask yourself the big question. Is there a pile now and we're pulling off the pile? What are the payments doing? That's the main thing. Ask yourself, are these payments tearing down, coming off a big pile now, or are these payments building up for a big pile later? What are the payments doing? Coming off or building up? Number 2, are the payments coming off or building up?
Building up.
To become. There's the key phrase, right? To become. So if they're becoming something, they're building up for a future value. That's future value. It's a pile later, right? Okay, so then, since it's future value, we go up and we go, okay, it's one of those 2 future value formulas. Which one is it? Well, it depends whether the payments are made at the start or the end. Which one is that?
Ordinary.
It's made at the end, so that's same formula again. So that's future value ordinary, future value ordinary. We've had 2 in a row. They'll be more mixed up on the real exam. That is one thing that's different. I mix them more. All right, number 3. Try number 3. What interest rate is needed to accumulate 75,000? So ask yourself, are we building up or pulling off?
Building up.
Yeah. To accumulate. To accumulate. That's building things up. If you're accumulating wealth, you're building it up. So where's the pile? Are we coming off a pile now or building up for a pile later?
Building up.
Building up for a pile later. Future value yet again. Future value again. All right. So it's one of the 2 future value formulas.
Ordinary.
At the end, it's another FO. It's 3 FOs in a row. Like I said, I'll mix it up more in the real test. Let's go to number 4.
Well, on number 3, you end up having to graph that one?
Yeah, I want to do that one full out if we have time.
How do you know that you need to graph that equation?
I'll show you. It take me a lot. I got to do it to show that. Yeah. Let's go to number 4. Find the amount that will be accumulated by me. So ask yourself, what are the payments doing? Are they building up for later, or are they coming off a pile now?
Under future due.
Where's the pile? Is the pile in the future, or is the pile now? Yeah, accumulate again. We're building up for a pile later, so it's future value. Now, is it ordinary or annuity due? Yeah, right. It is FD, isn't it? Because it says somewhere, beginning, right there, beginning of each period. Right? That's annuity due when it's the beginning. Exactly. Whoops. Good. All right, number 5. Where's the pile? Are the payments coming off a pile or building up for a pile? Accumulate again. Future value. Okay, is it ordinary or annuity due? At the beginning. It's an FD again. All right, future value. All right, let's go to number 6. As soon as you read purchase a home, we're talking house payments, right? How do house payments work? You got a big pile of money you owe, right? And you're trying to pull down that pile for the rest of your life, right? Trying to pay off that house, right? So it's present value, isn't it? Pile now. House payments, car payments, present value. You have the car now, you have the house now, right? The bank gave you the money to buy the car now, the house now, right? You owe them that big pile, and you're pulling down that pile. So it's present value. Present value, and for present value, there's only one formula. Don't even worry about anything else. There's 2 for future. There's only 1 for present. So that's all. So got it. That's all I need. Present value. It's good. It's going to use this present value formula right here. Make sense? Don't even need to distinguish beginning of the month, end of the month. Who cares? There's only 1 present value formula. They didn't give us 2 types. That was only for future value. All right. Good. Number 7. Greta wants to retire. Read this one carefully. Don't just read the word retirement and stop. This is a trick question. Read the whole question and ask yourself, what are the payments doing? 30-year period equal, oh, I'm doing the wrong one. Down here. Withdraw. Do you withdraw to build things up? When I go to the bank and withdraw, does that make my pile build? No, that tears down my pile. Even though it said the word retirement, normally retirement, you're saving. Normally when we speak of retirement, we're on this end. I'm not 65 yet, right? We're on this end. I don't think any of you are either. We're on this end of retirement, so we're storing up for retirement. But that's not what she's talking about. She's talking about after she retires, how much she can withdraw from the pile, right? The way you can distinguish that is again, the focus that'll really get you to get the right answer is what are the payments doing? She's talking, what is the month-by-month thing doing? Is it building up or tearing down? Well, it's saying that she's withdrawing. So she's going to be pulling off the pile. So she must be talking about a pile now, or at least at retirement, that she's going to then pull off $12,500 at the end of every 6 months for 14 years. That's a present value. Trick one, huh? Because it's talking about how she can pull off, what kind of pile she needs at retirement to be able to pull off what she'd like to pull off for the last 14 years. Make sense? See how we distinguish that? Again, everybody catching the main distinguishing mark. The distinguishing mark are the payments building up or tearing down. If they're tearing down, it's a pile now. If they're building up, it's a pile later, right? Those payments are withdrawals. They're tearing down. All right, we need a fresh, so let me go to a fresh screen here. All right, there we go. We got number 8. That's a lot of words. Yeah, 8's a confusing one. Look at the time. All right, suppose you win the power lottery, blah, 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 blah. Yeah, this would be a good one to do. It's not a lot of time. 360 million, this amount will be divided evenly over 30 years. Stop right there and just get that number. It's good sometimes just to stop and get your hands on a number. They're going to pay you 360 million divided evenly over 30 years. What is that? Let's take 360 million, divide by 30. It's 12 million per year. Right? So that's what they're saying. They're saying we're going to pay you 12 million at the end of every year because you won this lottery thing. Right? 12 million at the end of every year. All right. You'll receive a check at the end of each year. Yeah, right. 12 million a year for 30 years. If you decided instead to receive the whole cash value now, what does that sound like? Pile now. Present value. Present value. Pile now. They would pay you They would not pay you the whole thing. Instead, they would pay you an amount that could be invested today. They'd pay you some amount that you could put in the bank at 5.4% interest and provide the same amount of payments at the end of each year for the next 30 years. So what is that pile now? It's a present value. What is the pile now going to be to pay you $12 million a year? The payments, that is the payments, right? You want some big pile now that'll pay you $12 million a year. So now, if I was you, if I was sitting in your seat, I'd probably be thinking, what do you mean? That's just the 360 million, isn't it? Like, how's that going to be different? It's the 360 million. That's the 12 million a year for 30 years. What do you mean that's 360? No. The trick is it's going to be lower than 360 because it's going to be growing in the bank. So they won't have to give you the whole 360. They'll give you something like 300 maybe. And you put it in the bank, and it's yours. And you put that 300 in the bank, and yeah, it pulls 12 million off the first year, but it grew during that year. And it keeps growing, it grows and you pull 12 million off. It grows and you pull 12 million off. It's getting lower and lower and lower because you're pulling off more than the growth. But it didn't need to be the whole 360 million. It's lower than that because it'll grow throughout those 30 years to be more than it originally was, right? So the real answer is going to be below 360 million. They'll pay you less. If you want it now, you get less. That's basically the deal. Yeah, so there's a whole formula, and I just have so much time. It's all written out there on the. I don't think that one is the hardest one in the world. I'd like to do number 3, maybe. Let's see. I meant to roll the screen. This screen doesn't roll. All right. Let me mention this. All right. See how 9, 10, and 11 say you must show your work by hand, not just solve the calculator. Ignore that. Calculator is okay.
Thank you, Jesus.
That's it. Jesus reigns over all things. I'm convinced. But I used to be a mean teacher, and now I'm a nice teacher.
Wow.
I mean, there's just too much. There's too much material in this class, is what it really is in the end. We're only 3 units, and we have a ton of stuff. So I'm scaling some things down. So remember, we just did our calculator on those things, and that's all you have to do. You know what I mean? That's just RREF. That's just put that into your calculator. 2, 3, 5. See, I'm just doing this right here. 8, 12, 20. And just do RREF and hit the buttons, right? That's all you have to do on this one, this one, this one. Just use your calculator. That's fine. That's all you got to do. Oop, I tried to roll the screen again. Okay. Yeah, the whole deal on this one is, do you see these zeros right here? Zeros all the way. That 0, 0, 0, 0, 0 means infinite. When you see that, it means infinite. See this one right here? When you have 0, 0, a bunch of zeros and then a number. Let me separate this. This one, okay, let me rewrite it just to be clear. This one, when you have a bunch of zeros and then like a number that's not 0, that means, okay, come on, no solution. So you want to know, just by looking, that's the results of an RREF. That's what they're saying. They're saying somebody did RREF and they got that, or they got that. What does it mean? Well, I'm telling you, what you need to put on your 3x5 card is if you've got zeros all the way across that's infinite, if you've got a bunch of zeros and a number that's not 0, you're not supposed to have that. That's no solution. So the no solution one, we're just done. Nothing more to do. The infinite one, though, I have to give you a little more help. Let me help you with that. This is going to be all we're going to be able to do with our time, it seems like. So the infinite one right here, what you have to do is put back in the letters. 1, 0, 0, 0. Oops, I'm using up way too much space because of my finger. So for this one, you gotta put 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 3, 0, negative 2, 0, line 13, negative 8, 6, 0. So you gotta put X's down the first column, then Y's, then Z's, then W's. So this becomes X, right? 1X plus 0 plus 0 plus 3w equals, this is the equal sign, right? The bar, 13. The second equation becomes 1y, right? 1y equals negative 8. The third equation becomes 1z, z minus 2w, right? 2w right here, equals 6. Do you see those three equations that I got from that system? You see how I did that? I just put x's down the first column, then y's, then z's, then w's, equal signs, and the numbers, right? And I just turned them into equations. This is what you have to do on the infinite case. Then you solve for x, y is already alone, and solve for z. So how do you solve for x? Move that 3w over. So x equals 13 minus 3w. Y, like I said, is already alone. It's just negative 8. And z, move the 2w over, is 6 plus 2w. Everybody see how I solve for x, y, and z in those equations? Is that making sense? Am I losing you and confusing you? Right? So you put x's down the first column, then y's, then z's, then w's, and then just write out what those equations are saying. There's a bunch of zeros, so most of the stuff drops off. Then solve for x, y is already alone, and solve for z. Okay, so that's basically my answer. Let me go to the new screen. X equals, what was it? 13 minus 3w. Y equals negative 8. Z equals 6 plus 2w. Okay, that's the answer they're looking for. That's the infinite. But then I even ask for a little more. I say, okay, give me two particular answers. How do you do that? You pick values for w. So here we go. So you pick w is 0. You can pick any number you want. I'm just picking 0 because it's the easiest number I know. So I'm just picking w equals 0, and then after I'm done with that, I'm going to do w equals 1, because those are the two easiest numbers I know. You can pick 17 and 23 if you want. I'm picking 0 and 1. And then I'm just going to plug them in. X is what? 13 minus 3w, but now I'm putting in 0 for w. So that means x is 13. And y is negative 8, nothing to do with y. Z is what? 6 plus 2w. W again is 0, z is 6. So there is one particular answer. X 13, y negative 8, z 6, w 0. That's one particular set of answers. But then you could, I asked you for two particulars, so there's one. Then do it again with w is 1. So x is now 13 minus 3 times 1. So x is 10. Y again is always negative 8. Z, plug in 1, is 6 plus 2 times 1, z is what, 8? So x is 10, y is negative 8, z is 8 for w1. There's another set. See how it's infinite? See how you can just keep doing this and doing this and doing this? That's why we mean it's an infinite number of solutions. For every choice for w, for every number you plug in for w, you're going to get a set of answers. And I'm saying just show me two sets, any two sets. I just want to make sure you're getting the idea of what that means. Does that make sense on that? We are out of time, unfortunately. There's other ones that are valuable. I'd be glad to help you. Office hours tomorrow, 9 to 10. Roberto's available right now until 4:30 over there.
Test on Tuesday?
Test is Thursday, day after tomorrow.
Tried it.